Hello, Math 1. This lesson is on graphing linear and compound inequalities. This whole unit, you guys talked about solving inequalities, and we noticed that an inequality could have more than one solution, right? Therefore, we graph the solution to see what numbers, are part of the solutions. So let's review real quick. What is an inequality? An inequality basically refers to a relationship that makes a non-equal comparison between two numbers. So in general, it's a math sentence that uses greater than, less than, or not equal to. So when we look at it, greater than would be this symbol, less than is that symbol, and if we use not equal to, it would be that symbol. Now, a solution to an inequality is basically the values of the variables, or variable it should be, right, that makes the inequalities true. All right, so when we break this down, right, and look at the first example here, circle the values of x that are solutions to the inequality. So easiest way to determine which numbers are is just plug them in. So I'm just going to take everywhere I see an x, I'm going to replace it with 4. So 3 times 4 plus 4, is that going to be less than or equal to 7? Well, 12 plus 4 is going to be 16. Is 16 less than or equal to 7? No, that's not a solution. The next one, 3 times 1 plus 4, is that going to be less than or equal to 7? Well, 3 plus 4 is 7. 7 is less than or equal to 7. Because you have this little equal sign, that is going to be the solution. Next one, 3 times 2 plus 4, that's going to give you 10. Is 10 less than or equal to 7? No. When we look at negative 1, 3 times negative 1 plus 4 is less than or equal to 7. Negative 3 plus 4 is 1. 1 is less than or equal to 7. That is going to be a solution. So the easiest way to check if it's a solution or not is to plug it in and determine if it makes a true statement or not. But if we look, plugging it in could be tedious at times, especially if you're trying to determine if multiple values are solutions or not. So what we do is we graph the solutions. So right away here, when we graph inequalities, the first thing we do is we plot a point. Okay, now there's two things we got to worry about. If we're less than or equal to or greater than or equal to, this equal part is what determines it, right? If that is the case, we used a closed dot on the number we plot. And that closed dot tells us that value that we're plotting is a solution. If we have less than or greater than, meaning we're not equal to, that means we're going to use an open dot, like such. So a closed dot is if we're equal to, an open dot is if we're not equal to. Once we plot the point, we basically, second step is to shade. We're going to talk about that, individually with each example here. So when I look at this, remember, the one thing you have to understand is the shaded region represents all the values that make the inequality true, okay? So right away here, this is x is greater than 6. So what we're going to do is we're going to go to 6 on the number line. We are not equal to, this tells us we are going to use an open dot. We're going to go to 6. Now, where are all the x values greater than 6 going to be? Well, they're going to be to the right of it. And we draw an arrow to the right, and that tells me all those numbers are solutions to the inequality. So if I took a number from the shaded region, say 10, is 10 greater than 6? Yes. If I pick one that's not, say 0, is 0 greater than 6? No. That's why it's not in the shaded region. So the next one, the inequality is less than or equal to. So we know we're going to use a closed dot on 0. Now, x is less than or equal to 0. Where are all the numbers less than or equal to 0? To the left. Okay. Now the next one. X is less than 4. We're not equal to, so we know it's going to be an open dot on -4. And all the numbers that are less than -4 are going to be to the left of it. Now the next one. When I read this, I want to read from the variable to the number. Okay? So I want to read this like x is greater than or equal to 5. See how I rewrote it too? It's much easier for students to graph it with x on the left than the right. But in this case, I'm going to go to 5. I know I'm equal to, so it's going to be a closed dot on 5. And now, if x is greater than 5, which way am I going to shade? I'm going to shade to the right. Now, you could also use a test value, meaning I'll do it for the next one, right? I know I'm going to go to 3. Since we're not equal to, we know this is going to be an open dot, so I go to -3. What I'm going to do is pick a number to the left, right, or right. So say I pick a number to the right. So say 0. I'm going to use 0 as a test point. Is -3 greater than 0? No, that's false. Therefore, that's not in the shaded region. Therefore, I would shade the opposite way. If I plug a number in, say -7, is -3 greater than -7? That's true. Then I would shade through -7. So it's called using a test point to determine. Now, if we had to write interval notation and inequalities for each graph, right? Notice here, I know I'm going to use x, and we're plotted on 6. And when I look at it, if x is here, 6 is here, I know all the numbers are smaller than 6, so all the numbers that make it true are less than or equal to 6. Now, because that's a closed dot, that's why I put that little equal sign under. So here, I know I'm going to use x. I'm going to plot, it's plotted on -1. It's an open circle, so I know it's not equal to, but we're to the right. So I know all my x values are bigger than -1, so x is greater than -1. And the next one, x is going to be greater than or equal to 10. And I can always check my answer by plugging numbers from the shaded region in. So say 20. Is 20 greater than or equal to 10? Yes. So I know I wrote the inequality true. Now, a compound inequality is basically a sentence with two inequality statements joined together by the word and or. Now, and statements. And statements indicate that both statements of the compound inequality are true at the same time. So this and statement means both inequalities have to be true. Now, the solution to these and statements are the values of the variables that make both inequalities true. And we basically say it's the intersection of the two inequalities. So what happens here is if I have a compound inequality and it's an and statement, right, I'll have 2 points plotted, and we generally shade in between. Not all the time, but what happens is we'd probably shade this way, shade that way, and where do the two intersections intersect? Right there. Now, or statements indicates that as long as either statement, right, that's key, that either statement is true, the entire compound sentence is true. Meaning, we only need one inequality to be true. So the solutions here are the values of the variables that make at least one of the inequalities true. And we say this is the union of the solution sets. Okay, let's go ahead and take a look here. Now, right away, I know this is an AND statement. So I know x is greater than -3. So I'm going to go to -3, and I know I would shade right. Okay? But I also know and x is less than 9. So I'd go to 9, open circle, and I would shade left. Well, where do these two graphs intersect? They intersect in here. That would be my solution. Okay, number 2 is an AND statement. I know x is greater than or equal to -4. So when we graph the next one, you'll see when we graph this, x is greater than or equal to -4. So we're going to go to -4 on the number line. It's a closed dot because we're equal to, and all the numbers that are greater than are going to be to the right of -4. Right? Now the next one, x is less than 5. So we're going to go to 5. We're going to put an open circle, and that tells us we're going to shade to the left, right? Because x is less than. Well, where do you see, right, the intersection? The blue and the yellow created green, didn't it? And where did it create that green? In this shaded area right here. And this would be our solution. Right here. So the next one doesn't look like a traditional AND statement, but when I look here, these two inequalities are connected by AND. So what happens is if I graph this inequality, x is greater than 0. I know it's an open circle on 0, and I know I would shade right. The next one is x is less than 6, so it would be an open circle and shade left. Where do these two intersect? They intersect right in the middle here, and the yellow area is our solution. Okay, now, example 4. X is less than -3 and x is less than or equal to 8. So when I look here, this is a difficult one. So less than -3 tells me I'd go open circle on -3, shade left. But the next one is to be x is less than or equal to 8. So it's closed dot, I would shade left. But where do these two inequalities start to intersect? Because it's an AND statement, we need to talk about where they intersect. They don't start intersecting until this area here. So that yellow shaded region would be our solution. Does this happen a lot? No, but can it? Yes. All right. Now OR statements. If I'm connected by OR, I know right away x is greater than 3. I'm just going to go ahead and graph that. X open dot on 3. Greater than means to the right. There's x is greater than 3. Now the next one, x is less than -3. Go to -3, open circle, right? Shade left. And right away, that is the solution. Okay, leave it at that. Another OR statement, x is less than or equal to 5. Close dot on 5. Shade left. Open dot on 10. X is greater than 10. Shade right. Boom, done. All you're doing is graphing those individually. So now when we write the inequalities here, remember, if you're shaded in between, it's an AND statement. So I know x is in the middle. I know -18, right, is on the left. I know 6 is on the right. Now, I know all the x values to the right of -18 are greater than or not equal to, so it's a no line underneath. And then we're to the left of 6, and we're a closed dot, so we're less than or equal to. So it's x is greater than or equal to negative 18. X is greater than negative 18, less than or equal to 6. Now the next example is an OR statement. So all I'm going to do is write an inequality for the left side, an inequality for the right side, and I am done. For the left side, I always put x on the left. We're to the left of 9, so x is less than 9, or x, since it's a closed dot, is greater than or equal to 13. Once you have those both written, you have your inequality. So go ahead, try the student practice, and let us know if you have any questions.